I'm going to use this formula here to build a Java wireframe application that you can see above. So let's get straight into it. So I'm going to start with an empty sheet. I'm going to create the project and build a UML class diagram. Okay, so here's a design. We've got a console, which is a frame, so that would be the window we're looking at. And in that frame, we've got the wireframe view and the control panel, which are the two panels. The wireframe view is where we're going to look at the view of the graphic, and the control panel is where we're going to be able to adjust the settings. Control panel is going to have a bunch of sliders that set settings in the projection class, and the projection class main method is convert. That's going to convert a 3D point defined in the model to a 2D point for drawing on the screen. So let's implement this. Okay, so what I've done so far, I've got the main class, the wireframe, and that's constructed. It builds a console frame and adds a listener so that when that frame closes, the application exits. Console frame sets its size and it sets itself into border layout, and it adds a control panel to the east and a wireframe view to the center. The wireframe view is just an empty panel, and the control panel is a panel in flow layout with a couple of sliders added to it for testing. So let's have a look at how it looks. I forgot to set the window visible, so I'll just do that now. And there I cannot see the sliders, so there's something not right. Okay, I had the initialize method, but I didn't call it, so let's try again. And then we've got a couple of sliders. We need some labels for those sliders, and we really want them to be vertically going down. So I'll set this into grid layout, and I'll get these sliders for all the different values done next. Okay, so I've added 6 sliders, 3 for the position, which will be the position of our shape relative to the center of rotation, and 3 for the rotation. So let's just check that that looks okay. It would be nice if it is a bit smaller, but we'll keep it like that for now. And then this area over here is where the graphic will be drawn. Okay, so if I go back to my UML diagram, so we built this. I'll build the projection next, and then we'll build a simple model and get it drawing. So the projection, I'm going to need the 0.2D and 0.3D objects to be added also. So let's get on with that. Okay, so at the start in the main class, I create a projection and a model. I've changed model to an interface, and I've made a class that implements that interface called cube. We'll take a look at that in a bit. When I build the console, I pass it the model and the projection. That projection then gets set into control panel, and as the sliders change their values, I've added a listener for each of the slider, and that will call the relevant setter in projection. And the next thing I'm going to do is I'm going to add a listener, projection listener, and I'm going to make the wireframe view a listener to that, and I'm going to have that output I'm going to add a toString method to projection so that we can see the values in it, and I'll get it so that when we move the sliders, the wireframe view will output the string that represents the projection via a listener. So let's do that. Okay, so I'm passing and saving the model and the projection into the console, and the wireframe view is getting those. We want to add this as a listener to the projection, and then the projection, it has a listener. Every time any of the values in it changes, it will call the notify change method, and that, if the listener's not null, will notify that a change has happened. And then we've also added a toString method to the projection to output all these parameters. And the wireframe view, when the projection changes, it will set its string to be that, which is initialized to test. And when it paints itself, it will paint that string on the graphics. So let's test to see. Okay, so we have test there. When we move a slider, we should see the full projection string. We should see the value changing. Okay, that's not quite working. I knew why straight away. It's because the panel isn't repainting itself. So all I need to do when test string changes, just call repaint. And now the sliders should work. What's happening there? That's very strange. Okay, well the image isn't clearing itself, so we're drawing the strings on top of each other, but I'm surprised to see the sliders appearing up here. So let's have a look at that. Okay, so I'm just going to fill a rectangle in the background of the panel in white and then draw the string in black. I haven't attempted to fix the appearance of the sliders. That does seem to work though, so we've got X position changing in that string, Y position changing, Z changing, X rotation changing. For the rotation, I've done it from -180 to 180 on the sliders, so that's in degrees. The Z rotation. No, I don't know why the sliders were appearing up there, but we'll see if we can ignore that. So now I'm going to create the point 2D and point 3D objects. They're quite simple, they're just 2 numbers and 3 numbers. And then I'm going to create a cube model, and then we'll do the convert method on the projection. So let's get on with that. Okay, so after thinking about this a bit more, I originally, I think in the UML diagram, was planning to just have points in the shape, but actually I think we need to have something a bit more. So I've made a model drawing element, and that can have a type, and the type is either move or line. So I've added constructors to the point 2D and point 3D. The model drawing element has a type, it's either a move or a line, and it has a 3D point. And then for the cube, we're constructing two squares and the lines between the squares. So this should be the points of a square. Everything's either 100 or minus 100. Well, that will make it a square, 200 by 200 by 200. Get elements there should return these elements. And now I just need the wireframe view to read the model, run it through the projection, and draw it to the screen. To begin with, I'm just going to read the model and draw it straight to the screen just to check. Okay, and also it's going to be 2D to begin with, so I'll just read the X and Y values. So let's do that. Okay, so I'm reading the points out of the model now and drawing them. I've added an offset point 2D, and I've also added to point 2D an offset method that will take in the offset and return as a new point offset by that amount. That is just pointing to the center of the screen, and it's going to update for each paint method. So if we resize the screen, that will automatically get updated. If we're doing a line model drawing element, we'll draw the line from the old point to the new point. If we're doing a move or anything else, we'll just save the new point to the old point. Now let's see, we should see a square. I'm just doing a point 2D, so the thing I need to do is just convert it. Okay, so there's a square and the sliders do nothing. So now we need to implement the method, the projection convert method, and just convert the 3D point into a 2D point according to these settings and draw it to the screen. Okay, so let's do that. Okay, so now I've added into the when we get the point out of the model, I'm running it through projection convert. I'm doing that before offsetting it because I still want to move it into the center of the screen. And projection convert is running through these sine and cosine methods. Let's see, I think I've done those right. I was referring to some code that I've written before that is actually a machine code, but luckily I had commented the method. So this is the formula we use to go through 3 stages of rotation. So let's try this out. I think that's pretty much complete now. So let's try moving the position. We don't see. Okay, that's the X and Y position moving. The Z position, we don't see it moving because we don't have any perspective. That's the X rotating, so we're rotating against the horizontal axis. That's the Y rotating against the vertical axis. And the Z should be rotating around the in-out line. Let me just reset that and see if that's doing what we what I'm expecting. So Z, I'm expecting it to rotate around. Yeah, it does. I think I need to convert the degrees into radians because it's rotating a lot. So I'll just do that now and then we'll test it again. Okay, so I've converted all of the rotations into radians and just try Z. Okay, so it's rotating nicely. Y and X. And also we can move the thing away from its center of rotation. Okay, so that seems to be quite nice. I'll just make a slightly more interesting shape. I think also it might be nice if we can animate this. So have the rotational values applied in each update. I think one more thing I might do to it is I'll have a repaint thread and I'll have it animated so that the sliders, instead of being just the rotational sliders anyway, I'll keep the positional sliders, but the rotational sliders I'll have them applied again and again so that the cube will actually spin. So let's have a go at that. Okay, so I've changed the 3 values that are being set by the sliders to X rot movement, Y and Z rot movement, and then I've added a thread. So when we construct this object, we're going to invoke it in the graphics thread. We're going to thread sleep for 20, and then we're going to update the rotations by adding the movement values onto it. Then we're going to notify the change, and then we'll ask the thread to run again. I've got those 20 millisecond delay, that may be too fast. So let's see how that works out. Give it some Z rotation. Okay, now we don't really want the option to be able to rotate quite so much now, so let's change the sliders now just to give us, maybe we should have fractions, but we'll just change them so that we can just go from -5 to 5. So that's in the control panel. I should really have defined these as constants, but okay, so that's the Z rotation, the Y rotation, and the X rotation. And we can also slide off the position. So that's looking quite nice. So we can see the values still changing. I've kept that test string in there. It would be nice to make a slightly more interesting object. I'll see if I can do a kind of really simple version of a Star Wars X-Wing fighter or something. So I'll just make the cube, put a cube inside this cube and connect the diagonal corners. I've got a bit of an idea. I'll have a go at making that. Okay, so this is my final shape that I'm going to do. It's supposed to be some sort of a simple old fighter jet from Star Wars or something, but You can see that if you had a more complicated 3D model, it could be quite interesting. So that's how wireframe graphics work. So if you have any questions, leave them in the comments, and if you'd like to see more fun little Java projects like this, then subscribe. So thanks for watching.